Hello friends, welcome to follow up. In this video, we are going to look at problem 3014, minimum number of pushes to type a word. So here, this is the first of such problems. In the follow-up video, we are going to look at the second of such problems. In this video, our main strategy will be integer division with remainder. First, we are going to digest the problem, and then we do the simple analysis, and finally we share two formats of codings. So one format is longer. The purpose is to demonstrate to you the final details. And the second one is compact, so that we can impose some mathematical computations. With that said, let's first look at the problem digest. So here we are given a word containing distinct lowercase English letters. So this is the key assumption in this problem, right? So here actually we can map the alphabet to 2 to 9, right? So like here, this is the one possibility, this then another possibility. So we can remap all the keys according to the rules given by the problem. So we want to return the minimum number of pushes needed to type a word after remapping the keys. So here the main point is that if you have such a map, let's say we map ABC to 2, then B is the second in this mapping, right? In this C string. So if you want to type B, you need to push the number 2 twice. Well, you want to push type C, you need to push the key 2 3 times according to the indexing of the characters in the key. So here, by indexing, we speak of one indexing, right? So with that said, let's look at the examples. So for example 1, so we have 5, the length of the word is 5, right? So the 5 unique characters. So there are many different ways to map, right? So as long as we choose 5 numbers out of this 8, because from 2 to 9, there are 8 numbers. So we are going to choose 5 out of them and then map A, B, C, D, E to the beginning of these 5 numbers. Then for each letter, we just need to push once to type them. So we are going to return 5 for this example. Well, for example 1, if you look at the length is 10, right? So we can choose 8 characters and map those 8 characters to 9, both inclusive. So this way, for those 8 characters, we just need to type once each. Well, we have 2 letters remaining. So we are going to map to the second of the 2 letters. We can choose 2 out of the 8 numbers from 2 to 9, both inclusive. But for those 2 numbers, for the 2 letters, you need to push twice each, right? So overall, you have 8 plus 2 times 2, that is 8 plus 4, that is 12, right? So this is the second example. So actually, you can think of longer ones, but for this problem, I would say the length is bounded above by 26 due to this assumption, right? Distinct lowercase English letters. So with that said, we are ready to look at the strategy. So basically, if the letter is less than if the length of this word is less than or equal to 8, right? We can assign each of the characters to the beginning of a number, right? So the result will be the length. So for the next 8 characters, for example, if your word is length is greater than 8, but less than or equal to 16. So in this case, the first 8 letters, we just push west, right? Because we can do the mapping. Well, for the second or the remainder characters, we just need to push twice by proper mapping. And further, you can consider next characters, right? So if for next 8 characters, so you're going to push 3 times each, right? And if you have further characters, for example, you have the length is 25 or 26, the last 2 characters you need to push 4 times, right? So that's basically the strategy. So here it does not matter. So which number you want to map, but the number of pushes is the invariant of the key. So with that said, first I'm going to write a longer solution, right? So here, you might notice that the length of this word is important. So we're going to have this one, and then we're going to look at the division of this length with respect to it, right? So if q equals 0, right, it means that this n is less than 8, right? So in this case, so we just need to return r, right? So this is the one, and then if q equals 1, right? So basically it says that you have more than 8 characters, but less than say 16, right? So in this case, the first 8 characters you're going to push once, so you're going to get 8, and then the remaining characters, that is r, right? So you are going to push 2 times, so we have 2 times r. So this is the one. Another case is if q equals 2, then in this case, the first 8 characters we can just push once, and the second 8 characters we just need to push twice each, and the remaining ones we need to push 3 times. We have 3 times r, right? So then if let's write here, if q equals 3, right, and then for this one, the first character 8 characters you need to push once each, and the second 8 characters you need to push twice each, and the third you are going to push 3 times, and for the remaining characters you are going to push 4 times, that is 4 times r, right? So actually this is a very detailed list of the possibilities. Let's do a test. Yeah, it passes all the cases. This is the one solution, but it's sort of verbose. So now that we know how to do this, basically we can write a shorter solution. Let me copy this part. I'm going to modify this one by version v1. See, let's copy this part, right? Oh, I already have it, right? Let's complete that. So basically, for the first, for the first 8 characters, you're going to push once. Well, for the second 8 characters, you're going to push twice each. So basically, the thing is like this. Basically, you get 8. If q equals 0, you get 8 times 0, right? And then if q equals 1, you get 8 times 1. So basically you are going to have up to 8 times q. So this is the number. Let's see, I'm going to use this. And then the remaining one you are going to do. So here the q equals 1, here I have 2. Here q equals 2, I have 3. Here q equals 3, I have 4. So here it actually is nothing but q plus 1 times 4, right? So we just need to return the sum. But for this sum, it's very easy to compute because the first one is, have 0 plus 1 plus up to q, right, times 8. Then plus q plus 1 times 4. And for this, the summation from 1 to q is nothing but 1 plus q times q over 2, right? But you need to multiply 8, so you're going to get something like this. So you're going to get return. So you can do 0, or you do this, times number terms, that is q plus 1, then over 2. But you need to multiply by 8, so you're going to have this multiplied by 4. But 0 plus q is nothing but q, so we just write q. And then you get, so you get, this is not times 4, right? The times r. This is q plus 1 times r, right? Also there's a common factor. You can factorize it, but it's not necessary. So overall, we just need this 3 lines. So let's do a test. Yeah, it passes all the cases. So this basically about it for this easy problem. So here the point is that we do integer division with remainder. So it's very elementary. However, this is good exercise, for both coding and for some simple arithmetics. So with that said, I guess that's it for this video. And in the follow-up video, we are going to look at the second of such problems. With that said, that's it. Thank you.